All right, everybody, we are looking right now at the topic 13 test review. And question number one is a pretty simple one. Okay, it asks us to find the area of the polygon. Okay, when we see that word polygon right there, that does not necessarily mean that we're going to skip to the third section of our notes and deal with that formula for a regular polygon. Okay, this in fact is not a regular polygon. This is just a parallelogram. Okay, you can see that these two sides right here on top and bottom, and the sides on the left and right are the same length and they're parallel to each other. So we're going to use that really simple formula, area equals base times height. That's all we have to do on this one, okay? There's a lot of information on this thing that we are not going to use, okay? Because you have to remember that the base and height are always perpendicular to each other, okay? Base and height on any of these problems, parallelograms, triangles, all of it, the base and height are always perpendicular. So there's always a right angle in between them. What that means for us is that these slant heights right here, these 5.8, that is extra information that we do not need. Okay, the only base and height, the only numbers that we're going to use are this 6 and this 5. Okay, if we're doing base times height, it's just a matter of 6 times 5. So our area is going to be 30 square meters. On your Canvas problem right here, you don't have to put in the square meters part. You can just put in 30, and that'll do the trick. Going on now to question number two. Question number two is a triangle. So again, we're going to be using that same idea with base and height, except this time it's a little bit different formula. On a triangle, you still use that base and height multiplied together, except this time we're going to cut it in half. It's still going to be base times height, but now we're going to divide by 2. So there's only 2 numbers given to us on this particular triangle, which is convenient. So we can just multiply them together. 4 times 1.5 and then divide it by 2. We can type that into a calculator, or you can just do some quick little calculations on your own, just in your head, whatever you need to do. We can see that 4 times 1.5 gives us 6, and when we cut that in half, it equals 3. So that's going to be our area right there. It'll be 3 square inches on this one. Question number 3 is where we start mixing up the formulas a little bit. Okay, question number 3 is what we in the business call a trapezoid. And on a trapezoid, you've got a different formula that instead of just using base and height, those 2 things, on a trapezoid, the formula's got 3 things in it. You still need the height. We're going to go 1/2 times the height, but then we're going to multiply that times both of the bases added together. Okay, A and B right here, these 2 things are bases. That would be your 2 sides of the trapezoid that are parallel to each other. I'm looking at 5 and 8 are going to be the 2 things that you add together. So when we plug everything into this formula, use a different color here. When we plug everything into this formula, it becomes 1/2 times the height. Okay, remember that your base and height are always perpendicular, so it's going to be this 4 right here. And then in these parentheses, what we're adding together is going to be 5 plus 8, which is 13. Okay, you can simplify this down, or you could type this in the calculator exactly as it is. 1/2 times 4 times 13. However you want to do it. However you want to do 1/2 times 4 times 13. It's all going to turn out to be equal to 26 square meters in this case. Okay? So your question is, as you're looking at this diagram, what is going on with this measurement in all of our calculations? And that's a trick question because absolutely nothing is happening with this measurement right here. Okay, this slant height on a trapezoid, the slant height right here, that is extra information. This is not involved in our calculations at all. We're only dealing with the height and the bases for this area. Okay, so that's what we're looking for right there is going to be 26. Just plugging the right numbers into our formula. Going on now to question number 4, it's yet again finding the area of the polygon. This time, our polygon is a kite. And as we look at a kite right here, dealing with a kite can be pretty simple because all you have to do is deal with the diagonals. On a kite, your area is equal to diagonal 1 times diagonal 2 divided by 2. Okay, that's all we're doing is take those diagonals, multiply them together, and cut it in half. So I'm looking at this vertical diagonal in the picture is 6 plus 6. So our diagonal 1 is going to be 12. Diagonal 2 is going to be 2 plus 10. So diagonal 2 actually turns out to also be 12. And then we're going to cut that in half. Okay, all we got to do is take 144 and divide by 2. In your calculator, that's a pretty easy process to go through. We've got a total area of 72. Actually, we don't have units on this one, so it's just 72. That's going to be our area. Question number 5 is probably the trickiest one on this whole entire assignment right here. Okay, question number 5 is probably the trickiest one, but it's really not that terrible. Okay, what we have, and you can tell because it's giving you these diagonals instead of giving you any side lengths or heights. This is a rhombus. Okay, and since this is a rhombus, we know that these two lines here in the middle meet and they make a right angle. They're perpendicular to each other. And we also know that each side, each of those two pieces are the same length. So as we look at this, you know what, I'll just go ahead and recreate that diagram on my little notes app here. Okay, we know that if this side is 4, then this whole entire yellow highlighted diagonal altogether is going to be 8. Okay, the whole entire yellow diagonal is going to be 8. Now it also tells us in the original diagram that this angle right down here is 60 degrees. What that means is that this right here, what I'm about to highlight, what I'm highlighting in green right now, that is a 30, 60, 90 triangle. And we know that there are special relationships between the side lengths on a 30, 60, 90 triangle. So if this part of it right here that I just marked, if that's 4, then that means this piece of it right up here is 4 times square root of 3. Okay, and if that's 4 times square root of 3, this thing is a rhombus. So that means this part down here that I just highlighted in blue is also 4 square root 3. So altogether, our whole entire blue highlighted diagonal here, that whole thing is 2 times 4 square root 3. Our blue highlighted diagonal altogether is 8 square root 3. So when we're dealing with this formula, the formula for a rhombus is the same as the formula for a kite. The area is equal to diagonal times diagonal, diagonal 1 times diagonal 2, divided by 2. So all we really have to do is take the two diagonals, our 8 and our 8 square root 3, and multiply those together and cut it in half. In the calculator, that's a very easy thing to do. All you got to do is 8 times 8, and then your second x squared gives you the square root. 8 times 8 square root 3, that'll give you a number, and then you divide it by 2. And that gives us a total of 55.4. If we're rounding to the nearest tenth, remember that nearest tenth is 1 decimal place. Okay, I'm going to go ahead and write that down to make sure everybody gets that. Nearest tenth, 1 decimal place. Okay, so I've got 55. It's a long decimal, what you get for an answer right here, 55.42562. Okay, we're going to round that off and just say 55.4. All right. Looking up next at question number 6. This is just like some that we had in our topic 13 homeworks. This is also a problem. I believe this particular problem with an octagon was the one that was directly on the notes. Okay, as we look at our octagon, we have to remember that all of these central angles down inside of here are just like a circle. If you took all 8 of those and added them all up, it would be equal to 360. So if we're looking for how much is one of them, Okay, for angle number one, we're going to do 360 divided by however many sides. And since this is an octagon, you can look around and count if you can't remember that octa means 8. We're going to do 360 divided by 8. So angle number one is going to be 360 divided by 8, which when you type into the calculator, that gives us a total of 45 degrees. Okay, so that'll be angle number one, 45 degrees. Angle number two is this one right down in here. Now you got to remember here that when you draw an apothem from the center point to the middle of one of these sides, that apothem cuts everything in half. Okay, as you look at this triangle that's made by the two radii in this octagon, the apothem cuts that triangle in half, and that includes this angle up here. So if we're looking for angle number two, all you got to do is take angle one and cut it in half. Okay, angle two is 1/2 times angle one. So that's 45 degrees cut in half. And angle number two, I ran out of room. Angle number two is going to be 22.5. Finally, we're talking about angle number three. Okay, angle number three right down here is our last one to look at. What I'm going to do here is I'm going to recreate the triangle that I'm outlining right here with the mouse. Okay, the triangle that I just outlined with the mouse looks like that. We've got angle number two up here. We've got angle number three down here. And our last angle is the one right down in the bottom left. That's a right angle. And we know that because this other side of it has a little box in it. So we already know that this angle down in here, the one that I just drew right there, that's 90 degrees. We already decided that angle two, that one right there, is 22.5 degrees. You just have to remember that every single triangle that's ever been created always adds up to 180 degrees. And so all you have to really do is subtract it out. Okay, if we're trying to find angle number three is going to be 180 minus those other two that we already have. Okay, because if we take out those other two that we already have, that'll leave us with this last angle that we don't have. Okay, so if we do that just real quick, 180 minus those other two angles, it gives us a total, if I can get my calculator to work right, gives us a total of 67.5 degrees. Which, if I'm remembering that correctly, that is exactly what we got when we did this problem on the notes packet. Okay, check that notes video and make sure I'm correct on that. But I believe that's going to be at 45 degrees, 22.5 degrees, 67.5 degrees. Moving on now to question number 7. Question number 7 is asking about a regular hexagon. Okay, so that word hexagon, and this is something you might want to put on a cheat sheet when we're taking this test. That word hexagon is telling us that we've got 6 sides. It gives us an apothem length, and it gives us a side length, and it asks us to find the area of it. Okay, if you're dealing with a regular polygon, you need to remember that formula is going to be perimeter times apothem cut in half. Okay, that's perimeter times apothem cut in half. So if we're talking about the perimeter of a hexagon, we have to take that side length and multiply it times the number of sides. We've got a side length of 15, and we've got 6 sides since this thing is a hexagon. So our perimeter is just 15 times 6. Doing that quick math, that gives us a perimeter of 90. And it straight up tells us right here that the apothem is 12.25 meters. Okay, so if we're dealing with that, that gives us that gives, I mean, that is both of the things that we need to plug into this formula. There's your perimeter. Apothem, it already said, was 12.25. So that's the other thing. And we just plug those in. 90 times 12.25, all cut in half. We punch that into the calculator. I get a total of 551.25 if we're rounding to the nearest tenth. Remember that we need to keep that at one decimal place. So that's going to give us a total of 551. We're going to go 0.3, round that up so that we're in the nearest tenth. Question number 8. Question number 8. These figures are similar. Okay, this is from our very last section of notes, 13-4, day 4 of the notes. And it says that the figures are similar, and it's asking about the ratio of perimeters and the ratio of areas. Okay, so if you'll remember back to day 4 of those notes, really the only thing we have to remember here is that if you can find the scale factor between these two shapes, it is really easy to find the ratio of perimeters and the ratio of areas. Okay, so let's talk about the scale factor. If we set this up, if we set up our ratio, we can see that the corresponding sides that are labeled 18 and 30. Let's set it up. Our proportion is 18 to 30. Okay, that same ratio is going to hold for all of the sides, even if we don't specifically know what the lengths are. We know that these two are 18 and 30, so if we set up that ratio, you can type that into the calculator, or you can just reduce that fraction down by hand. It's not that crazy of a fraction to reduce. It comes down. If you're using the math frac, or if you're doing it by hand and dividing by 6, you get a total of 3/5. Okay? This right here is not your final answer. That right there is your scale factor. Okay? What that means is that if we multiplied 30 times 3/5, that would give us 18. Okay? That's what the scale factor means. So, if that is our scale factor, that means our ratio of perimeters is the exact same thing. If you'll remember that chart on the bottom of the first page of the 13-4 notes, the ratio of perimeters equals the scale factor. Okay, so the first part of your answer right here has to be 3/5. We can automatically take out this answer here and this answer right here. You automatically, right off the bat, know that they are not going to be correct. The other thing we need to remember is that your ratio of areas is the scale factor squared. Okay, so if we're talking about ratio of areas, that's going to be 3/5 times itself. Instead of 3/5, it becomes 3 squared over 5 squared, which is how we get our other answer of 9/25. Okay, don't just multiply those things times 2. It's not the same. We have to actually square the thing. 3 squared and 5 squared, so it's 9/25. Our final question, number 9. Find the area. This is another one of those area questions. Find the area of a regular decagon. Regular decagon with a side length of 12, apothem of 18.47. All right, let's see this here. A regular decagon, and this is something that you might want to put on that cheat sheet again, okay, that list of stuff that I put on the back board over there. Regular decagon. So a decagon, when you ever see that DEC, it's just like in your science classes. That means you've got 10 sides. So that means our perimeter with a side length of 12, that means your perimeter is going to equal 120. 12 times 10 sides. The apothem, it already tells us right there, 18.47. So if we're plugging those two things into our formula, all we need is 120 times 18.47. those two things multiplied together and cut in half. Punching that into a calculator real quick, that gives us an answer of 1,108.2, if I'm doing that math all correct. All right, and that should do us. Okay, so on your test tomorrow, make sure that you've got a cheat sheet, some things that you might want to put on that cheat sheet. All these formulas for areas. Okay, on a parallelogram, it's base times height. On a triangle, it's base times height divided by 2. On a trapezoid, you've got to have 3 things for that one. On a kite and a rhombus, you have to have the diagonals instead of your base and height. You might want to write down something about 360 divided by a number of sides. You maybe should keep track of that one half perimeter times apothem. You should write something about the ratio of perimeters and your scale factor. Okay, all of that stuff is related to each other. That's all we're going to have for the review. And if you have any questions, just let me know. We'll see if we can get it all sorted out. That'll be it. Y'all have a good one.